Okay, so definition of a function with a metaphor. What that's saying is that a function is like a machine. You drop in an input, like let's say at 3, and an output pops out, like let's say an 8. And you have to be able to count on this machine to be consistent. If I drop in a different 3, it better not come out with a 9. It should come out always with the same output. Now, is it okay to drop in a 3 and get an 8? And then drop in a 4 and also get an 8. Is that okay? Yes, it is. It's still considered a function. Okay, so let me give you a list here. There's 3 different ways, and as you saw on the concept list, ordered pair was one of them. 2, 7, 3, 9, 4, 0. Would this be a function if it was all the possible outputs on all the possible inputs? In other words, that's all the points there are. Was it a function or not? Yes. If I add this in, 4, 0, now, is it a function? Yeah, because it was consistent. It came out the same thing. How about now? No, because now 4 came out with a different output. So, all right, good enough on that. Next topic is, if it was a graph, how can you tell if this is a function or not? Vertical line test. By doing a vertical line test, you're just testing inputs. Like, I'm testing 0 right now, and it's giving me 1 output. Now I'm testing 5, and it's giving me 1 output. Now I'm testing 8. Now I'm testing 10. Now I'm testing -2, and it's giving me only 1 output. So if I make a little curly Q at the end here, now, not a function. Because why? I'm putting in like 25, and I'm getting, what? 2 different outputs. Okay, good. So that's how you test using the vertical line test. And the last one is about equations, and I wasn't super clear with you on this. I said you can't just say it's got an equation and so it's a function. Because do you remember, like, if you say x equals y squared, do you remember that one? Remember what that looks like? That's this guy. And is that a function? No. So you can't just say it's got an equation so it must be a function. But you can say, and this is the part I never really explained terribly well, and I want to explain it more clearly right now. If you can solve it for y, and only have 1 equation or 1 output, then it's a function. So would you please just solve that for y? Maybe you'll see why this is not a function. The question is not, can you solve it for y? The question is, can you solve it for y and only get 1 output? So using your finger or whatever, find some blank space. You're going to need to add a lot of blank pages on this guy, because I'm asking you to do a bunch of problems that I'm making up for you that are different from last hour to give you that idea where you could check 3 different videos if you wanted to see some new practice problems. Solve it for y. All right, so you just take square root, and then I end up with square root of x equals y, all right? So it only came out to 1 thing? No. What did I do wrong? When I took the square root of y, when I took the square root of y squared, you should add absolute value of y. And then that leads you to have 2 different answers. Just to clarify, the square root of x is not plus and minus. A lot of people just think, oh, just put a plus and minus on this. No, that's not what's happening. What's happening is when you did the square root of a variable, you ended up with the absolute value, and that's what leads you to have 2 different answers. Y is square root of x and negative y. Y equals the negative square root of x. So yes, you're going to have a plus and a minus, but it's not the way some kids think. Square root of x is y, and y equals the negative square root of x. So let me show you what the flaw is in the reasoning of just slapping on a plus and minus. If I go like this, and I say square root, x equals plus and minus 4. Then what you just said is that the square root of 16 is plus and it's minus 4. And that's wrong. The square root of 16 is only positive 4. The square root of 16 is just 4. But the square root of x squared is not x, it's what? Absolute value of x. And now you're allowed to break it into its 2 parts. Because an absolute value needs 2 things. What's in here could either be 4, or what's in here could be negative 4. So you say x equals 4, and x equals negative 4. That's a critical distinction that you have to understand, and that's one that a lot of kids don't get. They think that the square root of something is two things. Square root of 16 is -3 and +3. Nope. This symbol, even if you get into it deeper, you look up that symbol, technically that symbol is the principal square root of, which forces whatever your answer was going to be to positive anyway. +4. Okay, enough about that. So, could this be a function? Prove it. Yeah. Can't prove it by putting in your calc. No, you can't. No, you couldn't. Because you're not using a calc right now. All right, so y equals 3x over 2 minus 5 over 2. And an amazing number of kids think the slope of this is 3x over 2. It's not. What's the slope of this? 3 over 2. Okay, good. So is this one equation that came out? Then what is it? It's a function. Yes? Oh, can you put a big over 2 like this? Yes, this is legal, but the downside is much more difficult to tell like what the y-intercept and what the slope are and stuff. But you're not wrong. It's right. Oh, sorry, 2. You just wanted to divide everything by 2. Yes, you can divide everything by 2, but I prefer to break it down only in the context of an equation like this because it tells me the y-intercept and it tells me the slope. Oops, I forgot the negative. No, it's not a negative. It's an equal sign. It tells me the slope, which is 3/2. There we go. Okay, good enough on that. Now, that was 3 ways to tell if something is a function. Next thing is called family of functions. I'm going through that list that was at the beginning of this smartboard or near the beginning. Families of functions. So, there were 12 of them. There were 12 different functions. Do you remember that there were 12 of them? There were 6 of them you already knew coming in. So I will expect that you would for sure know what that function is. What function is that? Absolute value. How about the one that looks like that? Square root. Good. And how about some of the new ones? Somebody name one of the new 6. Can you name any of the new 6? Yes? Sine. How do you tell sine from cosine? It's how they start. Do you remember where sine starts? Yes? Yep. Sine has nowhere to go but up. Okay, and the cosine starts at 1 and goes down and makes a valley. It's all downhill from here. Okay, good. And how about the logistic function? Do you remember that one? Okay. Maybe some of you should go back and study your functions. So there's 12 of them. And it wouldn't be that hard to find the notes from a couple days ago that have all that functions listed in there. All 12 of them are listed in there. Okay, so here's the logistic function. Remember how it goes up and has a limit on it, so it's good for populations? Like let's say you wanted to have a model for a population that was going to end up being 1,000. Then you'd go y equals 1,000 over 1 plus e to the negative x. You should know that function. If you haven't memorized it, write it down and memorize it now. It's one of the 6. I just gave you 2 of the other 6, so you got 3 of the 6 already listed. Go find the rest of them. All right, enough on families of functions. Other than, you should also be familiar with what changes are happening when I say something like this. Make that let's make that a 4. I want to use different numbers, so when I refer to the 2, you'll know which 2 I'm talking about. There we go. Okay. So on this one, there are 1, 2, 3, 4, 5 things that have happened to the simple little squared function, otherwise known as the parabola. Would you please make a quick sketch out of what each thing is called? Like one of them, for example, is called a vertical stretch. Try to remember what all 5 things do. This is a classic higher algebra topic. You spent probably a month on learning these so that you would be really good at it. A month might be a stretch. Probably 3 weeks. Okay. You know, I should give you a little bit more time. We're started again. So, back here, we went through a couple functions not on the recording there. That's okay. That one, that negative in front, that is a vertical reflection. In case you've forgotten the whole vertical horizontal thing, the ones on the outside are verticals because it's vertical on the outside. Anything on the outside, that's a vertical. And on the inside, they're all horizontal changes. Horizontal on the inside. So I like to think of this as high-vo. High-vo, high-vo. It's off to math we go. Anyway, so that's a vertical reflection. The other one's a vertical stretch. Raise your hand if you had those two right. Okay. How about the horizontal on the inside, that little 2 there? Did you think that was a stretch of 2? Because it's not. Because you can't trust the things that are on the inside. They're always opposite of what you would expect. So that is not a stretch of 2. That is a shrink, or a, what is that called? It's another fancier name for shrink. It's smaller by a factor of 2. Anyway, so it's half as wide. How about that? And then the last one, or the last inside one, is that -4 there, and that's horizontal again. Horizontal could imply left or right. What is that? Right 4. And the last one is the -8, which is what? Down 8. Okay, good. All right, moving on. That was under the topic of families of functions. Now let's talk about domain and range with an A and a B, or a B. Okay, so here's a normal parabola. Let's say I shift it up A. Now what's its range? Actually, tell me its domain and range. I'm going to shift it up some amount. I don't know. I'm going to call it B. Would you please figure out what the range of and domain of this function are now? Okay, I've been asked a good question. They said, does A have to be positive? And I will say yes, A is greater than 0. Because if I move it up A and A was actually a negative number, that'd be tricky. It could happen, and then it'd actually be moving it down. No, A is greater than 0. Okay, so did you know then that the domain was from -infinity to +infinity? Raise your hand if you had that right. Okay, good. The other part is the range, and the range then is from how low to how high. It's from A to infinity, but I think I did something wrong there. What do you think? Jack? You need a bracket. You're right, because if it touches at 0 and I move it up exactly A, it'll be touching at A. All right. Next, here's a little more complicated one. See if you can tell. There's an asymptote line there. Let's say my function goes like that. What's its domain and its range? I don't know what the asymptote line is at. Let's call it A. But is it really A then, if A has got to be greater than 0? It was moved a distance of A. Yeah, domain and range. So if this thing was over here, and then I moved it over A, then what's this domain and range now? Okay, so here's domain. Domain, how far left can I go? -A. Good. Can I be on -A? No, because there's an asymptote line there. Very good. How far to the right can I go? Infinity. Range. How low can you go? -infinity. And then how high can you go? Infinity. If you reverse those two, it'd be wrong. You have to have the smaller number on the left and the bigger number on the right. All right. That's enough about domains and ranges with A's and B's. Let's do piecewise functions. This I nicknamed a Franken function. X to the third, where I'm going to say this is only true where x is greater than 5. And it's going to be 1 over x minus 4 when x is between -1 and 5. And it could be -1 and it could be 5. And it's going to be 4x minus 9 when x is less than -1. All right. So this is 3 different functions all in one. If you were to get a picture of it, just for perspective, do you get that the dividing lines are really at 5 and -1? So here's x being -1, and here's x being 5. Think of this as 3 different graphs. It's one graph in this zone. Which is that? A, B, or C? Part A is that zone to the right. The middle zone right in here, it's a different graph. In that little zone, what zone is that? A, B, or C? That's B. And then C must be over here. Okay, now if I was going to make a graph for these, I would make an XY chart for each one of them. And on my XY chart for this area, it only makes sense to pick really small numbers because you have to be less than -1. So here's my XY chart, and I'd only pick numbers less than -1, like -2 and -3 and -4, etc. And then for the XY chart for this little middle zone, I'd only pick numbers that are between -1 and 5. Okay, like -1, maybe 2, 3. Sure, anything between -1 and 5. And maybe 5. Okay, so you'd pick a bunch of things there. And then the last one, I'd have an XY chart for it, and I'd only pick numbers that are bigger than 5. Like 6, 7, 8, etc. All right, so my question is, instead of making you find all of those points and then being able to graph, let's say the thing ended up being, you know, like some kind of a thing like this over here, and then in the middle, it was like maybe like that in the middle, and then over here, it was like empty spot here, and it was a line going up like that or something. I don't need you to graph all of those for me. Let's just find a couple points. Why don't you find me f of 5? And why don't you find me f of -2? Find me f of 5 and f of -2. Okay, we're back, and I am doing f of 5. I'm sticking a 5 in. Well, which function should I use? A, B, or C? B. Okay. And why am I using that one? Because this one, it says a 5 in it, but it only allows it if x is bigger than 5. My x is not bigger than 5. Won't work there. Has to work here. So then I pick this one, and then I stick a 5 in, and then I have 1 over 5 minus 4, which is 1 over 1, which is 1. Raise your hand if you had that. Okay, good. Do you get that this means the point 5, 1 is on my graph? That's what this means. X is 5, y is 1. So 5, 1 over 5 up 1 would be on this graph. Now, I don't know a lot about the rest of the graph. Let's try f of -2. We stick in a -2. I hope you realize that went into this function, c. Raise your hand if you put it in the right function. Okay, good. And did you get 4 times -2 makes -8. -8 minus 9 makes -17. Raise your hand if you had that. Awesome. So -17, and that means the point -2, -17 is on my graph. So -2 is that right on that line? Nope, it's just a little past it. So it's like -2 is like over here, and then I go down 17, so it'd be a spot way down there is on my graph. I need a whole lot more dots before I figured out exactly what this graph looks like. But you've evaluated a few spots on a piecewise function. All right, now I have the stretcher for you. You signed up for an honors class, right? So see if you can handle this one. What is f of a plus 1, given that a is less than -8? Think. You can do this. The hamster on some of you guys' wheel just fell off. But some of you is squeaking, so I could tell you is still running on the little wheel inside your head. Here's what you should have been thinking. Okay, if a is less than -8, then it could be something like, what's something less than -8? -9, maybe -9. Okay, and if I'm doing f of -9 plus 1, that would be like f of -8. Do you get that this whole thing in here is a fairly largish negative number? So then I have to pick this one, because that's where the x's are negative numbers, or largest negative numbers. Okay, so I know I should use that one. That was the biggest job. Now that I know I should use that one, I just stick a plus 1 into that function right there. So now it's 4 times the quantity a plus 1 minus 9. This would be a sad mistake. Do you get why that would be wrong? And not just because the -1 and the -9 could go together. There's something wrong with that. Oh, wait, there's two things wrong with that. Now, that would be a more common mistake answer. Yes, sir?
When you're multiplying by 4, 4 is divisible.
Yes. Think of this as an empty parentheses. There's a parentheses around this. Now that means the 4 has to get distributed to both. Okay? So I would take this and write it as 4 empty spot minus 9, and then I would drop in my a plus 1. And now I'll have 4a plus 4 minus 9, and that can all go together and say 4a and the plus 4 and the minus 9 will make a minus 5. 4a minus 5. Raise your hand if you had that before I did. Awesome. Okay, so that's evaluating a Franken function. Yeah, that's the answer. That's it. I just asked you to tell me what f of a plus 1 was. That's it. That's it. Now, I'd have to tell you what a was in order to actually find a point. Okay, I didn't use -9 either, really. But you needed to have this 9 in the problem. Did you use that 9? Okay, good. Now, I just acted like -9 was a number to tell me which function to use. So, like, I needed to find something that was, a was less than -8, so I could have used -9 or -10 or -50. But the main reason I needed that was just to tell me, oh, I guess then this number will be a small negative, and therefore I should use this part of the Franken function, the piecewise function. All right, let's move on. The next topic is called implied domains. I'll give you a problem that has an implied domain. This is a word problem. I'm launching a rocket. I'm doing time and distance. Give me an implied domain, as in time is my x, my domain. Nope, time. Sorry. Because time is always your independent variable, needs to go on the bottom. This is distance. Distance the rocket has flown. What's my implied domain if I am launching a rocket? What do you think about time? X. Can x be anything? No, can't be anything. Because what can't it be? Negatives. You can't have negative time. Okay? So, therefore, that's an implied domain. I didn't say it, but you could have inferred it, or I implied it. So, let's say that I make my graph looks like that. Little flare at the very end because the rocket is programmed to like launch its little parachute right at the end or something. And okay, so now I'm going to give you this in function form. f of x is equal to, let me think here. This is implied domains. Negative 16x squared plus 2x all over x minus 4. Now, this is not a normal equation for a parabolic flight, okay? But just assume for a moment, I was trying to give you a real-world context of the rocket. Now we're going to go away from that and just say, here's a function. What's its domain? Remember, what you should ask on this is domain means what numbers would work. And some of the numbers would poison this function. So you always answer the question by going with a big answer, like everything works except what in this case? Some of you were way overthinking this because you're trying to solve the top. I didn't ask that. I asked what's the domain. And that just means everything will work except that can't be 0. So what can't x be? All right, so what you should do on problems like this is set this not equal to 0. And if it had a square root in it, you would set those greater than or equal to 0. All right, so then the moral of the story, x must be not 4, and therefore it can be, if I make a number line for this, any answer works for x except 4. So here's 4, can't be that, could be this, could be this. All right, so that was a fairly easy one because it only had a denominator that had issues. Can't let the denominator be 4. So here's one that's a little more complicated. Let's say this is x minus 8, and this is all over x squared minus 144. Would you please figure out for me what the domain of this function would be? I'm going to call it g of x. Pause while you figure that one out. Okay, you should have right away snapped into a mode of that can't be 0, and that's greater than or equal to what? 0. So x minus 8 greater than or equal to 0. Solve it. Add 8, x greater than or equal to 8. And then this part, not equal to 0. If you can factor it, you should. So I factor this, x plus 12, x minus 12, and I get, it's not supposed to equal 0. So what are the two things that would make it equal 0? 12 and negative 12. So x cannot be 12, and x cannot be negative 12. And now I put it all on a number line. That's my best advice on these, is try to take the red writing there and the green writing here and put it all together on one number line. Here's negative 12, can't be that. Here's 12, can't be that. Here's 8, can be that. And you got to be careful now. It says bigger than or equal to 8. Should I just color right through the 12 or not? No, because if you do, you're saying that 12 is fine. No, 12 is not fine. It's going to crash the bottom. Even though it doesn't crash the top, it crashes the bottom. So you got to leave 12 out because that's poison. All right, so from 8 to 12, the bracket on the 8 and a parenthesis on the 12. Now, if you wanted to write this in interval, do you get that this would go like this? 8 to 12, union 12 to infinity. Does that make sense to you? Okay. All right. So that was implied domains. Now let's do making functions. Here's a function. And let's say the directions had been, I want you to give me a function that's going to add 4 first, and then multiply by 5, and then divide by 3. Does this one do it for you? No. What if I said, I want your function to divide by 3 first, and then when you're done with that, add 4, and then times by 5? No, this isn't working for that. Okay, so my question is, I'm going to tell you now what the directions are, and I want you to make a function that does it. I want you to have the function start by adding 5, and then I want you to be then divide, I'm going to use a divide by sign, divide by 7, and then add 6. Give me a function that does that. Okay, so this one must be pretty easy if people finish pretty fast. I want to add 5. Did you have an x in your function? Okay, good. And then I need to add 5 to it. Can't argue with that because I've only got one thing. As soon as I add the next thing, I'll be able to tell if I'm doing it right. Then divide by 7. Would this work or not? No, because it would force, if you started this problem from the beginning, you'd be forced to take 5 divided by 7 first because of the order of operations. So how can I force this to add the 5 first and then divide by 7? Yes, sir? All over 7. And that would do the same thing as some people say parentheses. Well, you get by dividing by 7, you are putting parentheses there automatically. Because when you have a giant fraction, if you didn't know this, newsflash, if you have a big fraction, there are implied parentheses on that giant fraction. That's important to know. That's why when you put this in your calculator, you got to be really careful. Because if you type in x plus 3 divided by x minus 5, it'll think you mean to just divide those two first. Okay? Do you see, if you really want this, you need to have the parentheses here. And if I put it in that way, there's implied parentheses on a big fraction like that. Okay, good enough. And then add 6 at the end, plus 6. That would force me to do it in the right order. So just double check yourself. I know everybody's going to have a plus 5, a divide by 7, and a plus 6 in their answer. So don't just slap this together. This is an easy type of problem. Be careful when you're done that you go through the directions and say, would mine really make the 5 add first? Yep, because it's got a parentheses there. Would mine really make the divide by 7 come before the add 6? Yeah, because divide comes before add, so it'll be forced to do that. And then the add 6 would definitely be last because the other two are done. Okay. Now, let's talk about, let's see, real-world function problems is the next thing on the list. So, remember that rocket question I was giving you before? Let's say it's f of t is equal to negative 16t squared plus 4t plus 8. Let's say this is a new rocket put out by the maker of SpaceX. And let's say that he just is trying to be a good citizen and trying to get more United States citizens interested in engineering. And so he makes this really cool little rocket you can build and launch in your backyard. And you can like send gerbils up into space to become gerbil knots or whatever they are if they're up in space. And so did you hear about the guys that launched a GoPro with a helium balloon? And it got up so high with the helium balloon that it could see down on the Earth and see the curvature of the Earth. It was up so high. And the GoPro, then the balloon pops, and the GoPro took a half an hour. And keep in mind, the thing's traveling at 200 miles per hour then, because once the balloon pops, then you're falling at terminal velocity. The GoPro travels at 200 miles an hour, and even that 200 miles an hour took a half hour for it to land in the desert. It lands in the desert, and they had a cell phone on it, and they figured that the cell phone, they could track their cell phone. But unfortunately, the cell phone signal in that area, they looked at the coverage map and everything to make sure it would work, but no, the coverage map was wrong. There was no cell phone signal in the area where it dropped. But a lady walking her dog or something in the desert, who does that, finds the GoPro and delivers it back to them, and they get this amazing footage from outer space. All right. I hear you. I understand. It landed in sand. Maybe they had a teeny tiny parachute attached to it. Possible. Like the balloon that lifted it up there was gone. I know that. Maybe they had a little parachute on it. I don't know. But I know that the phone was broken when they found it. But okay, anyway, this is a problem where if I gave you t is 2, tell me that would be easy for you to evaluate if I told you that the time was 2. Okay, then what if I said that I wanted to know when did it hit 50 feet? Well, then you put a 50 right here. And you're solving for what? For t. And it's a quadratic. Have I mentioned a few ways to solve quadratics? If you can factor it, you should. And first of all, we should set it equal to 0. But that's going to be a pain to factor, right? So then, what solves all of these? Quadratic formula. And what other option do they give you that's really a smart way to use a graphing calculator to solve it? Graph both sides and see where they cross. In case you hadn't heard this before, it's true of any equation. Let me back it down to a really simple one. X plus 5 equals 7. Do you know what the answer is? 2. Guess what happens when you graph y equals x plus 5 and y equals 7? You graph those two and you see where they cross. Take a wild guess where they cross. At 2. You can do that with any equations where there's two equations set equal to each other. You just graph both sides of the equation and see where they cross. I've estimated that typically on 5 problems on the ACT out of the 60. All you'd have to really do is graph both sides of the equation and see where they cross. As long as you can graph two equations, see where they cross, get your answer on like 5 SAT or ACT questions right there. Granted, sometimes it's a pain in the butt to find the window. You got a big enough window to be able to see where the two lines are crossing. And of course, what you want then is what x is equal to, because that's what the equation has in it, is an x. Or in this case, a t, which acts like an x. Okay, good enough on sticking numbers into equations. Last is a kind of a review topic. What if I asked you to find f of 0? Think about this for a second. What did I just tell you x was equal to? 0. And therefore, what am I asking you for? If x is 0, I'm asking you for the y-intercept, aren't I? Okay, what if I wanted you to find f of x is 0? Did I just tell you the x or did I just tell you the y? I just told you the y is 0, and by asking you for y is 0, I'm really asking for the x-intercepts. Good. Okay, now here's one that's a little more complicated. 3x minus 5 all over x plus 2, and I want to know when is this function equal to 0? F of x equals 0. Where should I put in the 0? In for the x or in for the f of x? F of x. If f of x is 0, I want to make this 0. Now, this is confusing because you got a big fraction equaling 0. I'll give you a hint. You don't want the bottom to be 0. Otherwise, it'll crash, right? So to make this equal 0, all you care about is making what? The top 0. That look like an easy little equation to solve right there? It is. Okay? Give you another one like that. If I want to know when this thing equals 0, it's f of x, and I said f of x equal to 0, then do you get I don't even care about the bottom? I know it feels weird, but if the top was 0, it wouldn't matter what the bottom was, would it? If the top was 0, 0 divided by anything is still going to be 0. Okay, so I'd really just want the top to be 0. So could you set that equal to 0 and solve it? Sure, it's a quadratic. And you try to factor it. And if it wouldn't factor, what if it can't factor, you quadratic formula. If you can't factor, you quadratic formula. Or you could set both sides equal to 0. Y equals 0 and y equals that, and graph both sides and see where they cross. All right. Covered a lot of topics for you there. Keep in mind, I gave you several options for getting smarter over the weekend. Please utilize them and come back ready to roll. Have a great day.
Thank you.
Yep, see ya. Take care.